All right, we're looking at the logarithm functions today, section 4.3a. A logarithm is an inverse function to the exponential function. First, what we're going to do is we're going to look at how to type in logarithm expressions. So we see here a logarithm expression. This is log base 2 of 16. That's how you say this. This is log base 2 of 16. This is log base 2 of radical 2. This is log base 3 of 1. Log base e of 1 over e squared. Okay, that's how you say these. All right, when you have something like this right here, log base 2 of 16, what we're going to do is we're going to type in the calculator log 16 divided by log 2. That's how you type this in. Log 16, log 2. This number here is called the argument. This is called the base. We're going to do log of the argument divided by log of the base. So your calculator should have a log button. Here's my log button right here. So what I'm going to do is I'm going to just type in log 16. See, I put this parenthesis on, so I have to put this parenthesis to close it. Divide by log 2. Do the same thing, close it, and that's 4. Okay, so log base 2 of 16 is 4. Now what this means is log base 2 of 16 means 2 to some power is 16. What is that power? Well, it's 4. 2 to the 4th power is 16. So that's what this means. This means 2 to some power is radical 2. What is that power? All right, so we're going to type this in the same way. You know, when I type this one in, oh no, I'm sorry, we're going to B. We'll go to that one in a minute. We're doing log base 3 of 1. All right, so I'm going to do log of 1 divided by log of 3. That's what I'm going to do. Okay, so for this right here, log of 1 divided by log of 3. So as I type this in, log 1, close it up, divide by log 3, close it up, that's 0. Which I knew that before we started, because any log of any base of 1 is going to be 0. That means 3 to the 0 power is 1. And anything to the 0 power is 1. So anytime you have log of 1, log of any base of 1, this is always going to be 0. Okay, what about this one here? So when I type this one in, log of 0.1 divided by log of 10. So I'm going to do log, what is it, 0.1? Close it up, divide by log of 10. And that's -1. Okay, now we're going to do D. I'm going to do log. Okay, I'm going to do log of radical 2. So here's my radical 2, space over together radical, and close it up. Divide by log 2. That's 0.5 or 1/2. I think it says type a simplified fraction, so this would be 1/2. Okay. Now log of e, log base e of this. All right, so I'm going to type log of this, so it's going to be 1 divided by, and here's my e button. Remember that e is the natural log button, and this will be 2. I'm going to space over to get out of the exponent, and then put my parentheses, close it up. Then we'll divide by log of e. Now when I do this, this is just an e here, which is e to the 1 power. So like here, it's wanting me to put my power on there, which is 1. Okay, and then what is that? -2. Okay, and then one last one here. We got log base 1/2 of 8. Log base 1/2 of 8. So I'm going to do log 8, close it up, divide by log 1/2. Close it up, -3. All right. So if we scroll up here, we can see our answers. We got 4 0, -1, 1/2, -2, and -3. We're in good shape. Got them all. Here's one here. Just type it in, log 72. So I'm just going to type in log 72. Close it up. And there you go. Now look, it says round 4 decimal places. So as I look at this answer here, here's 1, 2, 3, 4. I'm going to keep those. Now look at the 5th one. Does the 3 make this 3 go up or stay? Well, it stays. So it should be 1.8573. Okay, so the 5th one makes the 4th one stay. All right. Logarithms get a bum rap because people want to think they're difficult and complicated, but they're not, really. They're not that bad. All right, look at this one here. Let's clear my screen. Log base 2 of 6. So I'm going to do log 6, close it up, divide by log 2. And I get this right here. It says round to 4 decimal places. So look here. 1, 2, 3, 4. Does this 6 make the 9 go up or stay? It does. It makes it go up to a 10, which makes this 4 go up to a 5. So you see here 2.5850. 2.5850. The 49 goes up to a 50. Okay. Same thing here. Log 0.77, close it up. Divide by log 9, close it up. And negative 0.11895, negative 11. Rounding it 4 places again. So see here, 1, 2, 3, 4. This 5 makes the 9 go up to a 10, which makes the 8 go up to a 9. So there it is. All right. Now, here's where we get into solving equations that involve logs. Okay, now before we go on to that, let me just show you guys a couple properties. I already showed you that if you have a log of any base of 1 is going to be 0. Okay, here's another one here. Log of any base of that same number. Log of any base of that same number is 1. So if these two numbers match, that's going to be 1, because b here to the 1 power is b. Okay, so if these numbers match, that's going to be 1. Okay. Then you have this right here. If you have some b to the power of log base b of some variable, these are going to cancel, which is just that variable. Okay, this is what we're going to be using a bunch in solving equations. When I have log of a base and I raise that as a power of that same base number, this will cancel off and it just equals whatever the argument is. Okay, that's what we're going to use to solve these logarithm equations. Now, you may not understand what I'm just talking about here, but I'll try to explain a little bit better as we go on to do some of these equations. On this one right here, see, I have this equation. I'm going to write it over here again. Log base 4 of x equals -3. Okay? Now, see, I got my variable right here in the argument. And I got log base 4 of that. All right, so what I'm going to do here is, since this is log base 4, that means 4 to this power should equal 4 to the -3 power. Okay, now why do I do that? Well, because these will cancel off now, and I have just x here equals 4 to the -3 power. And there's what x is going to equal, so I can just punch that in. All right, so I'm going to punch it in here. Close this off. Now this is 4 to the -3 power. So 4, here's my exponent key right here. Here's my exponent key right there. So 4 to the -3 power. All right, there it is right here. Now it says it wants a fraction. So hit math and enter. 1 over 64. So the answer is A. Okay. We're going to do some more like that, okay? But the thing is, when you have this base, log of this base, you raise it as a power. 4 to that power equals 4 to this power, and this will cancel off. It's the same thing we'll do here. Okay, let's, I got log base 4 of x equals 4. All right, see, I got log base 4 of x, and there's my variable in here. So I'm going to do 4 to this power equals 4 to that power. When I do this here, 4 to this power, that cancels, and I have just x. And then 4 to the 4th power, I can punch that in. So I'm going to do 4 to the 4th power, and that's 256. So x equals 256. And there you go. You see our answer there. Okay. Now there's a few more. Number 7. Okay. I'm going to write over here log base 4 of x equals 3 halves. All right, again, I got log base 4 of x. I'm going to do 4 to this power equals 4 to that power. And when I do that, these will cancel. X is going to equal 4 to the 3 halves power. So I'm going to type that in. I think that's 8. 4 to the 3 divided by 2 power. Yep, that's 8. There's the answer right there. Okay, now we're shifting up a little bit. This time we have log of base x minus 1 of 12 equals 1. Okay, all right. Now I'm pretty sure we're going to have some of these on our final exam. So let's make sure we understand how to do these. So there you go. We got log of this base of 12. So see this base here? So I'm going to do x minus 1 to this power equals x minus 1 to this power. So since these two things are equal, they'll be equal as powers of this base. Well, what happens here is this cancels just like the previous problems. So 12 is going to equal x minus 1 to the 1 power, which is just x minus 1. X minus 1 to the 1 power is just x minus 1, and then I can add 1 to both sides, and I get 13. And that's my solution here. So the answer is 13 right there, B. Okay. Let's do another one like that. So on this one, I got x plus 9 log base x plus 9 of 17 equals 1. Okay. But here's my base is x plus 9. Well, that means if I do x plus 9 to this power, it should equal x plus 9 to the 1 power. And then this right here will cancel off. So 17 equals x plus 9 to the 1 power, which is just x plus 9. And so then I'll minus 9 on both sides, and I get 8. There you go. X is 8. Okay. I think there's another one like that. All right, that's it. Okay. Now we're going to do graphs. Okay. Now, graph, if you remember, now this right here, this is the exponential graph. This is not the answer to this one. See, the exponential, if you remember, it has this tail that goes on the x-axis, and then it just blows up like this right here and just shoots up. This is the exponential graph. Okay. Now, the logarithm graph looks like this one right here. And I think this is my answer here because it's the only one that does this. But see, the tail goes on the y-axis. These are actually inverses of each other. And if you notice, if I try drawing this one over here on this one, if I try drawing it here, it does this right here, you can see if you draw this diagonal line like we talked about before, how these are symmetric about that line. Okay. But on this one here, log base 3 of x would be this one. Now this is an exponential here. See the tail is hugging the x-axis. All right, the exponential, all right, the tail hugs x-axis. That's what the exponential does. All right, the logarithm hugs the y-axis. The tail does. Let me put the tail. The tail hugs the y-axis on the log. On the exponential, the tail hugs the x-axis. So you can see that these two right here are both exponentials because the tail is hugging the x-axis. Here you can see the tail is hugging the y-axis, and on this one the tail is hugging the y-axis. These two right here are logarithms. But normally on the logarithm, the tail goes down. This tail here is going up, which means this one here must be a logarithm that's inverted. So it must be a negative logarithm. Like this could be negative log base 3 of x, which makes it flip and makes the tail go up. There's no negative in this problem here, so this is the answer here, A. Okay, you can see your domain and range. Your domain, all right, there's no values over here for x. So the domain starts at 0. See, the tail goes down here, which is x equals 0, and it goes this way forever. So that's your domain right there. Now your range, it goes down forever, and it goes up forever, because as this thing's going up, it's going up and up and up and up like this. So that would be my domain and range. We've got 11. Here's another graph. All right, we got transformations going on now. So like what happens here is, and maybe I didn't explain this clearly enough, but as this tail goes down, there's an asymptote that this tail rides. There's an asymptote on that axis. All right, so now what happens here, this x minus 2, see this 2 being in there with the x, that's going to affect it horizontally. And remember, it goes the opposite direction. So that's going to send it this way, which means if I was to graph that one, let's put a little graph over here. Okay. As I graph this one, 1, 2, the asymptote's going to move over this way. 2. See, it does the opposite thing here. It's going to send it that way. So my asymptote is here, and then the tail's still going to come down like this, and it's going to do this. And that's what my graph should look like, and it looks like A here. Okay, that's the graph. Now notice on this, you know this is not right because the tail is on the x-axis. See, it's going over now. It's shifted down, but this one's on the x-axis. These two right here are exponentials. So they're not, you should know that's not the answer there. The tail's going down. See this? Tail's going down. These two right here are logarithms, which is what we have here. We got a log function. All right, so the tail's going to be going down. So that tells me right off that it has to be one of these. And of course, this is transferred over too. Which means now my domain, it starts at 2 right here for x and goes this way forever. And then my range, it goes down forever and it goes up forever. Okay, I think there's another couple of ones. Log base 4 of x plus 2. Now on this one, notice that the 2 is not in the parentheses with the x, so we're not doing the log of the 2. Let me back up to the one we just did. See, this 2 is in here with the x, which means we're doing the log of it. Okay, which moves it horizontally. Well, this 2 right here is not in there, so it's not moving it horizontally. This 2 is going to move it up vertically. All right, so we got a log. Now look here. Exponential, exponential. These are out because they're exponentials. The tail is going horizontally. Here's what we got right here. The tail's going up and down. All right, now notice on this, this one's moved horizontally. Okay, that's not what we got going on. This is vertical, so this is out. D is my answer here. And I don't know if you notice on this, but this point right here is usually right there. So it's moved up 2 is what it's done. All right. Number 13 here. Okay, it's a logarithm. So which ones are not logarithm graphs? Can you tell me? 2 of these are not logarithms. Yep, right there, these 2. The tail's sideways. You see this? The tail's horizontal. Okay. You can spot the tail because it's either like going perfectly horizontally or perfectly vertical. See, this right here is not the tail. See, this is not going horizontal or vertical. It's going at an angle. See here, this is going at an angle. But the tail will always go horizontal or vertical on these. These 2 right here are your choices for the logarithm. It's got to be one of these 2. Now what you got to do is this plus 4. What does it do? Well, it's in there getting the log of it. See, we got the 4 in there with the x. So that's going to move it horizontal, which makes it go back this way 4, which looks like this one. This one actually has moved up 4 is what it's done. So the answer is D. So that's how you pick out the right graph. There's one more here. Okay. All right. Well, on this one here, this is a little tricky because this is a 1/4. And I think I may just take this one out because I don't think we're going to have one like this on our test. So I think I'll just take this one off. But what happens, this 1/4 being a fraction, that's going to invert it horizontally. Now, rule out which ones. Actually, all these, look here, the tail's going up and down. So all these are logarithms. So, but I'm going to take this one off so you guys won't have to worry about that. I don't want you to be confused since we're this late into the semester. But see this negative x. See, x is negative, which is going to invert it horizontally. And this is going to invert it vertically, which means the tail is going to go up. The tail is going to go up, and it's going to go to the left instead of going to the right. So this would be my answer here, B. But we won't worry about that one. Okay. Now, 15 here. We've got properties of logarithms. See, when you have a log of something like this right here and you got a product involved, you can split that up into individual logs. So what I can do here is, since I got this, I got 3 things inside here. That's a product and a quotient. So I can split that up. It's going to be log base 5 of x to the 3rd. Since I'm multiplying those 2, then it's going to be a plus. I'm going to have log base 5 of y to the 4th. Okay, and then down here I'm dividing by this 9, which means I'm minusing log base 5 of the 9. Okay, so now since I'm multiplying these 2, I can do log base 5 of this one plus log base 5 of that one, and then minus log base 5 of the 9. Okay, so that's the first thing I can do. Now what I can do from there, since this is an exponent here, I'm doing log of something with an exponent, I can bring this exponent out front as a multiplier. So this 3 will come out in front here. So it's going to be 3 log base 5 of just x now. Plus, same thing here. This 4 can come out in front of that one. So 4 log base 5 of y. And then minus, now there's no exponent on this one, so it's just log base 5 of 9. And this is what my answer should be. So is that this one? 3 log base 5 of x plus 4 log base 5. Yep. Is that right? 3. It says B, 3 log base 5 of x plus, oh, this is a plus right here. I didn't notice that one. Yeah. Yeah, it is B right here. It says 3 log base 5 of x plus 4 log base 5 of y, and then minus log base 5 of 9. So that's my answer right there. All right, we're going to do a couple more of those. All right, same thing here. Oh, look, there's 4 things in this, okay? So the top 2 are multiply ones, and the bottom 2 are divide ones. So that means I'm going to have log base b of m5 first, then plus log base b of the p squared. These 2 are divided, so they're going to be both minus. So minus log base b of n to the 8, and then minus log base b of b to the 6. Okay. All right, now these exponents can come out in front as multipliers. So this 5 will come out in front. So this is 5 log base b of m plus this 2 will come out in front. So 2 log base b of p minus this 8 will come out in front there, log base b of n, minus, and this 6 come out in front. Oh, look here, log base b of b. These cancel, so it's just 6. So we just did some of that stuff a while ago. These are one of our properties. Log base b of b will just be, they'll cancel. All right, now, let's see if we find that one. I think it's A. 5 log base b of m plus 2 log base b of p minus 8 log base b of n minus 6. The answer is A. Okay. We'll do a couple more of these. 17. Okay, we got log base 2 of all this. So there's 1, 2, 3 things here. So it's going to be log base 2 of 5 plus log base 2 of y, and then minus, because this is the division down here, log base 2 of z. Okay, now it looks like I don't have any powers. There's no powers, so I think I'm done right here. So let's see, log base 2 of 5, that says times. No. Log base 2 of 5 plus log base 2 of y minus log base 2 of z. Answer looks like C. Yep. And then 18. All right, see, there's 4 things in here. So I have, now this one here, there's no choices. You have to type this one in yourself. So this is going to be log, you just type log on the calculator, on the computer, I mean. So it's going to be log base 10 of x, right there. And then I got a y, so it's going to be plus log base 10 of y, and then these are minuses down here because they're dividing, so it's minus log base 10 of z minus log base 10 of t, and there's no exponents to pull out, so that would be it. Log base 10 of x plus log base 10 of y minus log base 10 of z minus log base 10 of t. All right. All right, now here's a couple. They're already expanded out. We want to get back to what it was originally, into the condensed form. All right, so if I notice, first I look and see, all right, I got this plus this minus this. All right, so that tells me they're all log base d, so I'm going to have log base d. You couldn't combine them unless they were all the same log base, and they all are. So what I'm going to have is, since these are plus, I'm going to have x, y on top. And since that's a minus, I'm going to divide by f. And so that's what my answer should be. Right there, it looks like C. Yep, C. Similar thing here on 20. I've got log base b of m minus log base b of n minus log base b of t. So I've got this. They're all log base b. And I got m and n on top, and I got t on the bottom, because I'm sorry, n should be down here because it's a minus. See, n's a minus. It's minus log base b of n, so it should be on the bottom with the t. See, both of these guys right here are minus, so they're both going to be in the bottom. So that's D in it. Okay. Now we're going to solve equations with logs. So you got 2 to the power of x equals 18. Okay, well, you solve exponents with logs, you solve logs with exponents. If you remember a while ago, we had an equation like this, log base 2 of x equals 5, something like this. So I did 2 to that power equals 2 to that power, and this will cancel. So x would equal 2 to the 5th power, which is 25. Okay, but on this, when I'm trying to show you, oh, I went on the screen. What I'm trying to show you is when I have a log, I raise that as an exponent. Okay, so 2 to this power equals 2 to that power. All right, if I have an exponent, I do the log of it. So since this is 2 to the power of x, I'm going to do log, here, let me write over here. 2 to the power of x equals 18. I spread this out a little bit. So that means log base 2 of this should equal log base 2 of that. Okay, and when I do that now, log base 2 of 2 will cancel, and I'll just have x equals log base 2 of 18, and then I can just type that in like we did earlier. So let's see here. This is going to be now log 18 divided by log 2. Log 18 divided by log 2. All right, so I get this here at 4.169925001 is what I get. Now it says round to the nearest thousands. What's 1,000 has 3 zeros, so thousandth is the third place. So 1, 2, 3 I keep. Does this 9 make that 9 go up or stay? It goes up. So it makes this go up to a 10, which makes the 6 go up to a 7. So 4.170. See. Okay, here's another one. All right, so I've got 3 to the x minus 3 power equals 24. All right, so since I got 3 and my x is in the exponent, I'm going to do a log, which means I'm going to do log of base 3 to both sides. So log base 3 of this should equal log base 3 of that, which this cancels now. Okay, and now I'm going to add 3 to both sides, so I have just x equals, and then I'm going to type this in. Now when you type that in, I'm going to do log 24. So I'm going to do log 24 divided by log 3, and then I'm going to add 3 for this 3. All right, so let me punch it in, I'll show you. I'm going to do log 24, close it up, divide by log 3, close it up, and then I'm going to add 3. And there you go. 5.8927, round to the nearest thousandths. So 1,000 has 3 zeros, so the third place. So 892. Okay. The 7 makes the 2 go up to the 3, so it should be 5.893, which is right there. Okay. All right. Same thing here. 2 to the 5x minus 1 power equals 12. So you see my x is in the exponent. I'm going to have to do a log. So log base 2 of this equals log base 2 of that. But this cancels now. So 5x minus 1 equals log base 2 of 12. Now you can go ahead and punch this in if you want to. I like to wait till the end. Like right here, I'm going to have to add 1 to both sides, which that goes away. So 5x equals log base 2 of 12 plus 1. Then I'm going to have to divide by 5. Okay, so that means I'm going to have log 12, close it up, divide by log 2, close it up, plus 1. There you go. You have to hit equals first, then you divide by 5. So 0.916 round in there is 1,000. 0.91699. We'll keep these. This 9 makes it go up to 7. 0.917. Right there, C. Okay. Solve this one. So let's see here. 2 to the x power equals 10. So that means log base 2 of this equals log base 2 of that. This will cancel. So x equals log base 2 of 10. So that's going to be log 10, close it up, divided by log 2, close it up, and 3.3219. This one here you got to type in yourself. It's 3.321928. There's my answer. Okay, you round 4 places. So 1, 2, 3, 4. So this is what I want to keep. Does this 2 make the 9 go up or stay? Well, it stays. So there's my answer. Okay, 25 here. Solve this equation. All right, so let me get another piece of paper here. 1/5 to the x power equals 14. All right, so since my x is in the exponent, I'm going to have to do log base 1/5. Log base 1/5, both sides, which means this will cancel. So x equals log base 1/5 of 14. So I'm going to do log 14 divided by log of 1/5. All right. Log 14, close it up, divide by log 1 divided by 5. There you go. So this is a negative 1.639738513. Okay, it says on here the nearest thousandth. 3 places. 1, 2, 3. All right, I'm going to keep this. Does this 7 make the 9 go up or stay? Well, it makes it go up. So the 9 goes up to a 10, which makes the 3 go up to a 4. 1.64 negative. There you go. 1.64. You could put the 0 on or leave it off. Either way, it'll take it. Okay. I think this is the last 4 problems here. So we're solving this one. Let me get this paper back over here. 0.5 to the x power equals 7. All right, so see my x is in the exponent, so I'm going to do a log. So log of base 0.5. Log of base 0.5. This will cancel. X equals log base 0.5 of 7, and you just type that in. All right, so log 7, close it up, divide by log 0.5. And I get the negative 2.807354922 is what my calculator says. All right, we are 4 places is what it says way down here. 4 places. So 1, 2, 3, 4. We're going to keep these right here. Does the 5 make the 3 go up or stay? Well, it goes up. Negative 2.8074. So there you go. Okay. All right, now here's some actual problems. The last 3 are word problems that use logarithms in real life. So suppose that this function right here models salinity of ocean water to depths of 1,000 meters at a certain latitude. Salinity is how salty the water is. Okay, so in the model, x is the depth in meters, and f of x is in grams of salt per kilogram of seawater. Approximate the salinity to the nearest hundredth when the depth is 659 meters. So I guess the deeper you go in the water, the more salty the water is. So what we're going to do then is the depth is 659, so I'm going to put 6. It says right here now, x is the depth. See there? X is the depth. So right here it tells us the depth is 659, so I'm just going to put that in for x. So basically you're just plugging this in and get your answer here. So I'm going to do it right here. You watch me there. I got 31.6 plus 1.3 times the log. So I'm going to hit log. And then in parentheses here, oops, I already got the parentheses, sorry. X plus 1, well 659 is x, and 659 plus 1 is 660. If you just want to do 659 plus 1, you can, instead of 660. And then there you go, 35.265 right here, B. Okay, so that's how much salinity you have. That's how many, what does it say here? The salt per kilogram of seawater in grams. So it's got 35 grams of salt per kilogram of seawater. Okay. Actually, 28 is the same thing. We've got this equation again, this function. Models the salinity of ocean water to the depth of 1,000 meters. Okay, approximate the depth to the nearest tenth where the salinity equals 31. All right, this is different in a sense that it tells us what the salinity is, which is your f of x. So if I put 31 over here, this is what I have. I've got 31 equals 29.1 plus 1.4 log x plus 1. All right, so I'm going to minus 29.1. because I got my log and x over here. This is going to go away. So now I can just do that real quick. 31 minus 29.1, which is 1.9. Okay, so I minus this on both sides, and that gives me 1.9 here, and that's gone over there. Now, right here, I've got this log, but I got 1.4 times it. I'm going to have to divide by 1.4. This will cancel. All right, so tell you what. Let me move this up a little bit. And now if I do 1.9 divide by 1.4, that's going to be a big old long decimal. I think we probably should keep all this. We don't want to round this because that may make our answer off when I do when I solve this over here, because see, I got a log over here and I'm going to have to raise this as an exponent, so I need to leave this as close to the answer as I can. So I'm going to leave all these numbers here. When I divide this right here, I get that. Okay, now this is one thing I didn't tell you, but see, this says log of this. There's no base here, which means this is base 10. This is log base 10. So I've got a log, so that means 10 to this power equals 10 to that power, which means this will cancel off. So 10 to the power 1.357142857 equals x plus 1. And so I can minus 1 on both sides and they give me x. So I'm just going to type this in now. All right. So I've got 10 to the power of 1.357142857. Enter, and then I'm going to subtract 1. 21.75845, whatever. Let's see what it says. Round to Well, it just has my choice here, so 21.8 is the closest one. Okay. And then one last problem here. The height in meters of women in a certain tribe is approximated by this right here. So this is a tribe. I don't know if it's in, I'd say some other country, like maybe in the continent of Africa or something. But the height in meters of women of a certain tribe is approximated by this function right here, or this equation, where T is the woman's age in years, and T is between 1 and 20. So you see here, here's the T, that's the age of the person, between 1 and 20. Estimate the height to the nearest hundredth of a woman of the tribe that's 4 years of age. So I'm going to put 4 in for T. So this one here, I'm just going to plug it in. So 0.52 plus 2 log. And then right here, I'm going to do 4 divided by 3. I'm putting 4 in for the T. So I'm just punching that in. So there's no solving here. So 0.52 plus 2 log. Then I got 4 divided by 3, close it up. And then it's 0.769877 meters. So 0.77 right there. See. Okay. And that's it. So these are logarithm functions. And you try them. If you have any questions, just give me a shout and I'll help you all I can. All right. So you have a great rest of the day.